Derive an expression for electric field due to an electric dipole A at a point on its axial line, B at a point along the equatorial line. Electric field due to an electric dipole at a point on its axial line. AB is an electric dipole of 2-point charges plus Q and minus Q separated by a small distance 2d. P is a point along the axial line of the dipole at a distance r from the midpoint O of the electric dipole. The electric field at the point P due to plus Q placed at B is E1 is equal to 1 by 4 pi epsilon naught Q by R minus D square along BP. The electric field at the point P due to minus Q placed at A is E2 is equal to 1 by 4 pi epsilon naught Q by R plus D the whole square along PA. E1 and E2 act in opposite directions. Therefore, the magnitude of resultant electric field E acts in the direction of the vector with a greater magnitude. The resultant electric field at P is E is equal to E1 plus of minus E2. That is, E is equal to Q by 4 pi epsilon naught into 4 RD by R square minus D square the whole square along BP. If the point P is far away from the dipole, then D is very less than R. E is equal to Q by 4 pi epsilon naught 4 RD by R power 4. Therefore, along BP, E is equal to 1 by 4 pi epsilon naught 2p by R cube. Since the electric dipole moment P is equal to Q into 2d. E acts in the direction of dipole moment. Electric field due to an electric dipole at a point on the equatorial line. Consider an electric dipole AB. Let 2d be the dipole distance and P be the dipole moment. P is a point on the equatorial line at a distance r from the midpoint O of the dipole. Electric field at a point P due to the charge plus Q of the dipole. Electric field at a point P due to the charge plus Q of the dipole. E1 is equal to 1 by 4 pi epsilon naught Q by BP square, that is R square plus D square, since BP square is equal to OP square plus OB square. Electric field E2 at a point due to the charge minus Q of the dipole. E2 is equal to 1 by 4 pi epsilon naught Q by R square plus D square along PA. The magnitude of E1 and E2 are equal. Resolving the E1 and E2 into their horizontal and vertical components, the vertical component E1 sin theta and E2 sin theta are equal and opposite. Therefore, they cancel each other. The horizontal component E1 cos theta and E2 cos theta will be added to PR. The resultant electric field at a point P due to the dipole is E is equal to E1 cos theta plus E2 cos theta along PR will give 2 E1 cos theta, since E1 is equal to E2. We know that E is equal to 1 by 4 pi epsilon naught. Therefore, cos theta is equal to D by root of R square plus D square will give E is equal to 1 by 4 pi epsilon naught P by R square plus D square the whole power 3 by 2. Since P is equal to Q into 2D. For a dipole, D is very small when compared to r. Therefore, d can be eliminated. E is equal to 1 by 4 pi epsilon naught p by r cube. The direction of E is along PR, which is parallel to the axis of the dipole and directed opposite to the direction of the dipole moment.
Please subscribe our channel for more videos and educational contents.